So the purpose of these notes is to help you guys remember the order of the scientists for the atomic theory. Democritus discovered tiny round circular ball-like spheres. You have to remember that. The hardest part to remember is the order of these tiny round circular ball-like spheres. Okay, I think it might get tricky when you get in this area, but if you spend time trying to remember the saying, then it'll help you when you're taking your quiz and you have to reorganize the theorists in order. Democritus, Dalton, Thomson, Rutherford, Chadwick, Bohr, and Schrodinger. Okay? And then the bottom table that you copied down yesterday are ways to help you remember their discoveries. So Democritus, he's first. He has that really old name. He's that ancient Greek philosopher. That's how we got the word atom, because the word atomos means indivisible, cannot be divided any further. And he's the person that said that if you cut up a piece of matter over and over and over and over again, eventually you would get to a piece that you couldn't divide any further. Okay, because remember that atoms are particles that, let's see, the smallest piece of matter that still has all the characteristics of that matter. All right. So then you have John Dalton. He took the atom even further. He's the first modern scientist to develop the atomic theory even more. He's the guy with the solid sphere that's indestructible, indivisible. He did a lot more with his ideas than Democritus. J.J. Thomson. So you have J.J. for plum pudding. J.J.P.P. Okay. He discovered the electron. And we'll see his model when we put up the information next. And then you have Ernest Rutherford. He discovered the positively charged nucleus, and he did the gold foil experiment to help him do that. So you have the N and the F for nucleus and gold foil. Niels Bohr, he's the guy that has now the electrons are in different levels, like the planets orbiting the sun. James Chadwick, this is the best one right here. Another name for James is Jimmy, and he discovered the neutron, so Jimmy Neutron. And then Erwin Schrodinger, he has the credit for the current theory, the electron cloud model. And so you have the E for electron and the C in his last name for cloud. Okay, so this is already recorded in your notes. Next, in your notes, is the table we had to make. I did two things up here for you. All right. All you need for James Chadwick is he discovered the neutron, and I crossed out the model box because there is no model. He just discovered the neutron. So you have this table already done in your notebook, and the next thing I'm going to put up is the information that we're going to use to help us fill in our table. Okay, so this page, I'm going to go over the whole thing first real quick, and then I will pause the video so that you guys can record all of this in your notebook. And if you're watching the video, you can pause also so that you can fill in your table. So Democritus, he's first. You see his model? All his model is showing is that matter can only be divided so many times until you get to a particle as small as an atom. All right. So he proposed that matter can't be broken down indefinitely, meaning forever. At some point, you would end up with a piece that can't be divided. He called that atomos, which is Greek, meaning indivisible. And then you have John Dalton. He's the first modern scientist to propose the existence of atoms. He described them as invisible, indestructible, solid spheres like a billiard ball. What's a billiard ball? What's a billiard ball? Oscar? What's another name? Pool. When you play pool. That's a billiard ball. The little balls on the table, those are billiard balls. Okay. And then J.J. Thomson, he proposed the plum pudding model. An atom is a solid mass of positively charged material with negative charges scattered throughout it. Okay, see that picture over there, the plum pudding model? I also, he referred to it as the plum pudding model, but I also think of it as a blueberry muffin, where the electrons are just scattered throughout the muffin. They're not separated like they are in the next model. The next model, Ernest Rutherford, his experiments prove that atoms are mostly empty space, and he discovered the nucleus. So now we have a model where there's the nucleus in the middle and the electrons are outside of it. Then Chadwick is next. I put a little line right here because that's where Chadwick goes. We already did that in our table, discovered the neutron and blocked out the model box. Now we have Niels Bohr. So he discovered that the electrons are actually in different orbits, like the planets going around the sun. And then the last model, Schrödinger. This is the current atomic model, that electrons orbit the nucleus in random paths. And the region where they are most likely to be found is called the electron cloud. Okay, so I'm going to give you some time to record this in your table, and then we will continue on to something else. Okay, to review everything that we've learned so far, here's a PowerPoint with some pictures. The atom is the smallest particle into which an element can be divided and still have all the properties of that element. Like blocking you guys, but my little thing's over here, so I'm going to move it. All right. It's determined by the number of protons in the nucleus. Remember when I showed you the periodic table and that the hydrogen has a 1 inside the box up there because it has 1 proton, and that's what identifies which element it is. Oxygen has 8. There's an 8 inside the box. That's how many protons oxygen has, and it determines what element it is. Democritus in 460 BC. You're going to see that years tend to be a little different all over the place. He was the first to come up with the idea that matter was made up of particles called atoms, coming from the word atomos, meaning indivisible. Here's a picture of Democritus. He's so old, it's a statue. John Dalton, he's next. He proposed the atomic theory. An atom is an indivisible, indestructible, tiny sphere. There's his picture. The nucleus is the center of the atom and is made up of protons and neutrons. The nucleus has a positive charge because of the protons. In 1912, Ernest Rutherford discovered the nucleus, and there's his picture. Protons have a positive charge. They're found in the nucleus with the neutrons. They are much larger and heavier than the electron. The mass of a proton is about 1,840 times that of an electron. When we went over the notes in the book, we learned that electrons are like 2,000 times less massive than protons and neutrons. Neutrons, James Chadwick discovered the neutron, 1932. They have no charge. Says they're slightly smaller than a proton. We said that they're about the same size. They are found in the nucleus. And isotopes are atoms of the same element with different numbers of neutrons. So they have different atomic masses. We learned yesterday that different elements cannot have the same number of protons. Okay, but atoms of the same element can vary in their numbers of neutrons, and they're called isotopes. Examples, carbon-12 and carbon-14. Carbon-14 has 2 more neutrons than carbon-12. Hence, 12 and 14. Right? Electrons are tiny particles with a very small mass that have a negative charge. J.J. Thomson discovered the electron. They are found inside the electron cloud surrounding the nucleus. Niels Bohr, 1913. He shows the number, the Bohr model shows the number of electrons in each energy level. Valence electrons are going to become something that are really important to you here soon. They are the electrons in the outermost energy level. So if you look at the pictures over here, hydrogen has 1 valence electron. Helium has 2. Lithium has only 1 on the outside. We're not counting all of them. You're only counting the ones in the very last energy level. And sodium has 1 because the other ones are all in the inner energy levels. And valence electrons are actually play a huge part in bonding, how the atoms bond together to form other substances. All right, the electron cloud. Notice it doesn't have Schrodinger's name on here. And it didn't have his name in the textbook either, because the efforts of multiple scientists suggest the current electron cloud model. It shows the region around the nucleus where an electron may be found. And because electrons move between levels, leaving a trace of where they once were resembling a cloud, well, it resembles a cloud because they leave a trace of where they once were. It's built upon the Bohr model, still suggesting levels. Right, and so the next thing we need to do is record the key, the element key in our notebooks.